is how to control anything that an Arduino can control with a remote control. And so here's the external materials list.
So what you're going to need for this project is, of course, first, an Arduino. It does not have to be this model or type. This is just a standard Arduino Nano with an expansion board. The only reason I'm using that is because it works good with these airplane controller wires. You're going to want whatever you want to control. In this case, I'm going to be using a couple NeoPixel LEDs inside of a lamp. You're going to want a programming/power cord that works with the Arduino you're using. In this case, it's just a standard mini USB. You're going to want a controller setup. In this case, I have the Spectrum DX6 6-channel DSMX telemetry system with its included receiver. It does not have to be this one, but this is just what I use. It works pretty well, and I just happen to have it because I was doing a project with RC planes when I started doing this. And because I'm using an airplane receiver, I'm also going to add in a power supply, which is just a high power ESC with its high power battery, just because I want to run this without my computer connected to it. And you could easily use the battery pin that goes onto the Arduino, but keep in mind that whatever you have plugged in there is not only powering your Arduino, whatever it's connected to, it also has to power the receiver, which in this case, if this thing gets anything less than 4.4 volts, it's not going to be happy. And this data line also outputs 5 volts, so it works for what I need. And you're also probably going to want some connector wires. It doesn't have to be these kind, it can just be whatever works for you. And that is normally what you need.
Then you're going to want to, of course, get a Arduino programmer that is compatible with your board. In this case, because I'm using the ATmega 328P, which is basically means I'm using a Chinese off-brand of a Chinese knockoff of the standard Arduino Nano. I have to use this old bootloader, which I found is only like really reliable on the 1.8.10 version, which is not the newest of the recording. But really, you have to do just do what you want to. Anyway, go ahead and make sure your controller, if you can, change the setup is on whatever pin you want, has its standard setup range, like no kill switches or anything, but like just goes smoothly up and down. On mine, it has a monitor on it, which I will cut to now.
On this controller, it has a monitor page that lets me see the values of each channel. And on this case, I'm using the throttle, which is all the way down goes to -100, all the way up goes to 100. I originally had a kill switch on it using that switch, but that was proving to be a little bit annoying with the code, causing random values. And I'm only monitoring this, so it doesn't really matter what the other ones are at, just as long as you can move this up and down, it'll work. Back to the computer.
So as long as you have that set up, it'll work. So you first want to label whatever pin you're connected to. For instance, if I'm using, I want my values to read out as throttle, which on the transmitter anyways, abbreviated to THR. And you're going to want to define it as a long variable because those variables hold on to their decimals and are a little bit faster and more accurate when it comes to math. I've tried using saying it's double or it's just like an integer, but it causes some weird problems with overflow. And you just say that before your setup code. Then in the setup code, you define whatever pin you're connected to as your input, and start the serial communication in this instance at 9600 baud rate. If you're monitoring multiple channels and are getting weird overflow or weird stacking problems, usually you're going to want to slow that down because the Arduino cannot do the math fast enough to be able to successfully send the command or send the signal to the computer. And you're also going to want to define if you have multiple pins, you should do that too. You should every pin that you want, of course, you're going to want to define. And then in your main loop, long again. I've tried it without saying long. It sometimes works, sometimes doesn't. Your pulseIn, which is basically it's monitoring as if it was a pulse width modulation signal or a PWM signal, which it is because it's coming from an airplane receiver. Then your input pin, and you want to monitor it when it's high. Now for now, let's get rid of these and just make sure you put, if you're using a long command, you have to put an L at the final number just so that the Arduino knows when to stop, basically. So if I upload this, oh yes, I need to put another parentheses there. Or it seems like it wants to have the L on the outside of the parentheses. Yes, so at this instance you are not ready for a long variable, so you can just define it as a double just for now. Make sure once you start doing math, you want to set it back to long, not double. Upload that. And let's take a look at the serial plotter. And in order to do that, you first need to get rid of the title, because what this command does is it labels it just types in this text, then it will type in variable as its number, and then go to the next line. But when doing the serial plotter, you don't want to really have any text in there. It can throw it off. So serial plotter, you can see these graphs, and this is just like variables or like pulses counted, basically. It's just time, and then you have variable. And right now, it is doing this bar graph at a maximum of about 1096-ish, and a minimum of around 1090. And this is with the throttle all the way down. If I start raising the throttle, you can see that the graph will go up, and then this is with the throttle all the way up. And let's let the graph resize. And this is what it looks like. So now that you know what the basic shape of your graph is supposed to look like, you can, and it's pretty responsive. There is sometimes a little bit of lag depending on where you are in the graph and how fast you move, and if you're monitoring multiple pins. But yeah, that's what that graph looks like. And now that you know the shape of your graph, you can do some cool things with it. All right, so now that you know what your graph looks like, you can open your serial monitor, and you're going to want to pay attention to some values. So you notice how it looks like it's staying at 1096, but this is with the throttle at its lowest value my controller can give it without adjusting trim, which would throw everything off. It says it's 1096, but sometimes it wavers. So in order to see that, you have to turn the auto scrolling off, and you can see now it's saying 1090, 1096, 1090, 1096. So you can see that the lowest value it'll ever get is 1090. So go ahead and define another variable, integer throttle min, which in this instance is throttle minimum, equals 1090. And you don't have to do this. You can just use it. You can just use the number as is. But unless this doesn't work, which I'm about to find out, I just like to use variables sometimes because it helps to keep track of what I'm using and where. Minus throttle min. And now, if you were to upload that, and open the serial monitor again, see it's staying at 6 sometimes, other times it goes to 0, other times it's at 5, that just depends on when it gets read. And then if you start scrolling up, you will see that it hits 801. Other times it's 890 or 795. Other times 794. But the highest it ever goes at a certain time is 801. Now that variable may be different for you guys. For anyone else, I'm pretty sure it just depends on what controller setup and Arduino you're using. But you want to keep track of these two variables, because now I can say integer throttle max equals 801. Now, now this is where the fun part happens, because now there's a lot of math going on here. So you're going to want to change this to long on throttle, long down here as well. And now, oh yeah, this is why I can't use variables here. I need an actual number to put the L next to, because in order to have a long variable, you need to put an L as the final number. So divided by 801L. So now what this does is it takes your signal directly from the pin, but minuses its lowest value to get it from a 0 to the maximum range, and then you divide it by its highest value so that you get a decimal version of percentage. And this is the point where it needs to have the long type of variable, because any other types of integer constants and stuff like that, it cannot handle the amount of decimal places reliably. As you can see, because I am using an integer here, and that threw off the math. So 1090, get rid of this. And oh, right. First off, let's for now just open that back up, and then you're going to want to divide this number by your minimum number by 100. So in this case, it becomes 8.01L. And now if I was to upload this, that basically is that's then saying divided by 801, then times the whole operation by 100, just, order of operations. I'll let 0, and then as I start to raise it, it starts going up, and it hits 100 sometimes. Other times at 99, usually it's at 99. So now you have a 0 to 100 scale that is nice and fast and reliable. You can do quite a few things with it. Let's add some other channels just so I can show you how to do that. Alright, so now you can see I've added 1, 2, 3, 4. I've added 4 more channels, and let me show you how I did that on the Arduino.
So this is basically how you add more channels. Just ignore this breadboard. I've just run out of the standard double-ended female connectors, and all I have are these female to male connectors, and so I'm just using this breadboard as just a jumper system so that I can connect all of them. Just start connecting them in order from your pins, and make sure you keep track of which ones are which. Let's go back to the computer.
And now, let's explain what's happened. So I have the throttle channel, the aileron channel, the elevator channel, the rudder channel, and the landing gear channel. All of those have their own variables. They all have been assigned to a specific pin. And then I've just basically copied the code with the specific labelings that I want. And actually these all should be changed, because this was an older version of the code. Again, if you're using the code that I've given you, or the code that you can download, you might want to change these values to, or you're definitely going to want to change these values to what works best with your system, because I haven't tested like any other systems, so I have no idea if any other systems are different. I'm assuming they are. But what happens is they get each value from its own channel, minuses it by its minimum value, then divides it by its maximum. And what this and so luckily on my remote each channel has the exact same range, so I don't have to do that. But if you notice that there are things that shouldn't be happening that are happening, you're going to want to go through each of them and test. And this is why and this is for testing is really the only reason why you want to use the division thing, because the value should be the same if you do it correctly for like when channels are at the same value. So let's upload that and see what it looks like on the serial monitor. So this is what it will look like at this point, because it is getting the name, giving it a number, putting a space, getting the name, getting a number, and it's doing that to 5 different channels. And you can see as I move each, as I'm currently, you just can't see it because I'm moving it in real life. I'm moving pretty much every control surface on the remote around, and it's going crazy with the values. And so so you can kind of see how it's like right now, nothing is moving. Like I have set the controller down, and the gear one is the only one that like is actually going to be 100% stable all of the time because it's assigned to a flip switch. Every other value you can see every so often. Throttle, it goes to 3. Ailerons, I haven't done it yet, but I've seen it change. Elevators sometimes hit 49. There it goes, 51. Rudder is jumping around 49 and 50. So, and this is only because of the rounding done because of the addition and not addition, by the division. And so what you're going to want to do is remove it and just use the raw values, which is what I'll show you now. So what you're going to want to do now is, if you want to use these, it's like control other things, you need to get more like values with a larger range, and dividing it by a number lowers that range and makes it, therefore you have to be more precise with your calculations. And sometimes you want that, but in this instance you really don't. So the best thing to do is do this and remove the division thing altogether. Make sure to leave that L right there, otherwise the Arduino will forget to be precise with it. I really don't understand it. I wish there's just a way I can say, just give me the number, which I guess this is, but not the way that I would expect it to. So now, that's what the code's going to look like. And this will give you a range, at least on this controller, of approximately 0 to 800, which gives me a much tighter and much easier time of coding it, because it is easier to land an area if you have 800 degrees to work with instead of 100. So let's upload that and see what it looks like on the serial monitor. So now, when you look at the serial monitor, you should see something like this. And you'll notice that all the values are now going to be their real values that they're getting out of the controller, just lower than normal. And although, yes, the gear is flipping around a little bit, that is just because of just like electrical interference and stuff like that. If you are noticing stuff like this, you should look into places where electrical interference can happen. For instance, I have the power supply pretty much right in the middle of the whole thing, and it's just a mess of wires that can be causing it. But yeah, this gives you 5 individual channels, and this remote's capable of 6. I just don't have another cable or I haven't coded another action on the remote for that 6th channel. But you can then use these values to program like the if, then, or switch case statements, so then you can use them for really whatever you want. And that will come in the next video. But for now, thanks for watching. Stay tuned for part 2 of this video, where you learn how to what you can do and how to do it with these remotes. See you later.